I welcome all the people from around the globe, from Nigeria, from Italy, from wherever they are joining us. The reason is that these kind of things have become very interesting in the world. Even as we're talking, under COP27, which is happening in Egypt, there is a schedule for materials like this, where a professor from EPFL, Professor Karen Scrivener, is giving a lecture on this kind of thing. So, people are very much interested in these things. So, without wasting time, I'm talking on this topic, the technical and economic and environmental impact of clay pozzolana utilization in Ghana. I think I have already been introduced, so there's no need for me to repeat myself. So with the introduction, I'm showing the world map. And the reason why I'm showing the world map is to relate it to population. There's a huge population growth around the world. And now we know that our population is about 8 billion. It has been predicted that in 2050, the year 2050, the world population will be about 10 billion from the current 8 billion that we have now. So what is happening in Africa? So this map will give us a very good idea of what is happening in Africa. So this is a graph plotted between a year between 1960 and 2020 against population relative to 1960. So if you carefully study this map, you see that the urban population in sub-Saharan Africa keeps on increasing. It is way going up. The urban population in the world is also growing. And then if you look at the urban population in the world, the rural population in the world, it is not growing, it is steady. But the rural population in South Africa, sub-Saharan Africa is also growing. So we can see that, yes, there's a steep growth with both rural and urban population in sub-Saharan Africa. And because of that, the demand for housing and other infrastructure in sub-Saharan Africa is very huge. It's not as huge in the developed countries because they've built almost everything. In the developed countries, when you go there, you don't see a lot of infrastructure development. Their forefathers did very well to build everything for them. But in sub-Saharan Africa, our population explosion calls for a huge demand for housing and infrastructure. Well, so let's look at the Ghanaian scenario. We have about 16 regions, and I picked this data from the Ghana Statistical Service. So it is between 2012 and 2022. So in 2012, our population was about 26 million. And of course, every Ghanaian knows that when they ended the census, our population in 2022 is about 33 million. So we know that by 2030 or 2040 or 2050, we are going to have a high increase in our population growth. Yeah, so the key question that we need to find out is that, well, is the nation meeting the housing demand? If I was to do a face-to-face presentation with you, I may have tasked somebody to answer me. That is the nation meeting the housing demand? Or are private developers also easing the problem of housing demand? Probably this picture is very interesting. Yes, so you can answer it. So this is a very nice building that is being shown in some area. So in most sub-Saharan African countries, you can see this kind of nice infrastructure. If it's nice, you can actually laugh in your head, but I think it's nice. And you see people are very comfortable in some places. When you go to Accra Circle, our capital, and you go to Dar es Salaam, you go to Kenya, you go to South Africa, in most of the cities, you see people are having a very good siesta, a very good night under bridges, so these are some of the accommodation we can actually have in developing economies. And so if we are meeting the housing needs, you can actually answer it yourself. So the problem can be viewed from different angles. And as a cement scientist now I'll put myself as a scientist, a cement scientist. Now, how do I view the problem from my perspective? So number one, not number one, but let me give an emphasis before. So we all know that in the country, Ghana, almost every construction we do is in cement-based material. So about 80 to 85% of our construction is from cement. Now, the point is that we have cement plants available in this country. Many years ago, we have a monopoly of cement plants. It was only Gasem that was producing cement, but it was broken. As I speak now, I'm told we have about 18 different companies producing cement in the country. But it's interesting that even though the cement monopoly was broken, now this is a takeaway information I'm giving you. Between 2000, the year 2000 till now, cement prices have increased by 3,400%. This is really huge. So, I mean, to back it up with data, I've been collecting my cement data for between 2000 and 2002. Before I joined BRI, every year I record it. So that has been the trend. And, you know, it keeps on increasing. It was quite interesting between 2021 and 2022 now. You see how the thing has really moved steep high. So that is the problem. We are having so much of cement price increases annually. So 3,400% from 2000 to 2022. And it is really a worrying issue. So because of this, it has really created problem with housing delivery. Cement-based materials are very expensive. For example, if you take about per meter cube of concrete, I remember 2 years ago, per meter cube of concrete was about 400 Ghana cedis. Yesterday, I picked a data from a concrete manufacturing plant, and for a C30 concrete, you can buy it around 1,300 or 1,400. So you can imagine. The reason for these prices, I think if we care to know, we have to depend so much on imports. But I think as the presentation goes on, we will actually explore that. So do we have feasible solutions? Yes, so if we are having problem with cement prices increases, then the best is that what do we use to produce cement? It is clinker and gypsum. So why don't we produce it locally? That is a long-term solution. But the question is that, is it possible for us to produce clinker and gypsum locally? We will answer that. So let me say that, I mean, we can produce clinker and gypsum. Our limestone in Ghana is not of a huge grade, a high grade quality to produce the high quality clinker that you need. But of course, we have one plant in Ghana by Diamond in Bupe, the Savasem, producing clinker. I met them recently in my office, and I think they shared their problem with me, the struggles they are going through to produce the clinker. I think next week I'll be at the cement plant for us to share some of these things and see the possible solutions that we can provide. So if we can produce clinker, what about reducing the clinker factor in cement? If we can reduce the clinker factor, for example, if I buy cement now, cement has been categorized. We have SEM 1 and SEM 2. In Ghana, you don't have so much of SEM 1, but SEM 2 is very common. So SEM 2 is using our 85% clinker, and then they add a bit of filler, which is limestone, and then gypsum. So can we further reduce the clinker factor in cement to, let's say, 50% or 60%, so that at least we can cut down clinker importation in the country? Because that is the bane of our problem. We import so much of clinker to produce cement, and we use a lot of foreign exchange to do that. So as the dollar goes up, of course, you have to know that, yeah, we're going to suffer the price. They will pass on the price to consumers. Yeah, so that is it. So these are some of the possible materials we can use to reduce clinker. We have pozzolans in a form of calcined clays, fly ash, and silica fume. And then we also have materials like fillers. Of course, I've mentioned SEM 2 now, which is produced in Ghana, where we use a bit of filler to produce it. And so it contains about 85 clinker and then about 15% filler. So we use chalk, limestone, talc, outside shells, clam shells. Then we can also use latent hydraulic materials, slags, to produce that. So then what can we also do is also using a mix of non-cementitious materials and cementing materials for construction. So if we can use a mixture of non-cementing materials and cementing materials for construction, then it means that we can actually do something about the cost. Now, I picked this work. This is a Ghanaian lady working on this. So this is a work of ram earth. Now, this lady used about 5% of cement and pick laterite earth and ram it with ramming machines and used to produce houses. And I think it's a very innovative way that we can use to build our houses. So what I'm saying is that we can get a mix of cementing materials, for example, the columns and the pillars, and then the beams can be made of concrete. And then we look at the non-cementing materials like ram earth, which virtually use a little of cement to reduce the cement cost. Yeah, so that is it. So we want to look at clinker factor reduction in cement. So with clinker factor reduction in cement, practically, we are using between 30 and 50% of supplementary cementitious materials to reduce clinker factor. That has been what has been done in the world. And we have advanced that, so that is what has been done. And when we do that, what we do is that we are either pre-blending or post-blending the materials, right? So you can pick a material and then use it at a cement producing company. So they have silos for the supplementary cementitious materials, and then they blend them together. So that is it. You can also do post-blending. So post-blending is when you are making your mortar or concrete on site, and then you come along with, let's say, a clay pozzolana or whatever, and then you blend it on site and use it for construction. Now, all these things have shown that, yes, we can improve the strength properties, which involve the compression, flexural, modulus of elasticity, dynamic modulus, and what have you. And then you also improve the durability of the material. So durability here in the sense of transport properties like resistance to aggressive ions and carbonation. So all these things are improved when we use these materials as a material that can reduce clinker factor. I did this work I think last year, where I replaced cement with between 10 and 50% of calcined clays. And I cured it at 3 days to 90 days to look at the performance. Now, what I did was to look at the common concrete grades we use in Ghana. Now, when you go to many sites, it's between C25 and C30. So I use C30 to design my concrete. So I normalize this to C30. So the zero that you see here is a normalized concrete of C30. And then what I did was to look at the 28-day strength. So at 28-day strength, even at 50%, you see that we're above the C30 concrete grade. At 30%, at 28 days, we're higher at this more than the C30 concrete grade. And then even at 90 days of curing, you see that, yes, we were still above the C30 grade of concrete. So it means that we can use these materials to decrease clinker factor and still achieve our desired strength if we limit ourselves to what is happening in Ghana and most sub-Saharan African countries. I did a little bit of durability tests. One of the common durability tests is to look at the chloride ingress. So if you, mostly durability has got to do with the pores within the material. So if you can look at how the pores are arranged and how easily some ions can flow through the material, then you can understand the durability. So I use the chloride, rapid chloride permeability test. And then I prepared this concrete. And of course, you realize that almost all the materials that were containing clay pozzolana had a lower ingress of chloride compared to the control. But the point is that we want to reduce costs. And so we are interested in higher volumes of replacement. So 10, 20 is okay, but let me look at 30, 40, and 50 because the higher I replace, the more savings I make. And so 30, 40, 50, they were similar. Yeah, so it gave me an idea that, okay, yeah, so let me look at all these places and then see. But it doesn't end there. We have to do so much of work on it to actually convince ourselves that these are very viable replacement that we can do. Okay, so let's look at economic benefits. So contractors are always interested in these things. With it, because I did some work on concrete, I prepared some economic benefits of it. Specifically, it's more of financial economic benefit. So this is it. In a concrete of per meter cube, this is the, so you see the control. I'm looking at the composition, the composition per kilogram. So with the cement, I'm using 406, 208, and then the rest are the various composition. Now, what we did was that we look at the costs per meter cube and the cost of producing a C30 concrete. I got 896 Ghana cedis. Now, I did 30% clinker reduction or cement reduction, replacing it with a clay pozzolana. And I reduced the cost by 5%. So I had 853. Now, at 40%, I reduced the cost by 7%. At 50%, I reduced the cost by 10%. That is very important. One of the most important thing I want you to note is this one. So just note the cement cost reduction. Now, with the control, the cement was 771 Ghana cedis. When I reduced it by 30%, I was getting 547. So in a nutshell, what I want to drive home is that you are reducing cement costs by reducing clinker factor or replacing it with appropriate cementitious material, and you are getting a reduction between 29% and 49%. So that is a key thing I want to drum home with. So two things you can see from this table. You are reducing the overall cost of concrete, and you are also reducing the overall cost of cement. Sometimes, you see, I always work with chemical admixtures in the form of superplasticizing agents. They are high rainwater reducers. In Ghana, people don't use that much, but I always encourage people. In my lab, I do a lot of concrete mix designs for clients. So when they come, I always do the design using chemical admixtures. Some people don't like going with the admixture. They said, okay, let me do it. But it's always safe for you to use chemical admixture because you are able to control the water to cement ratio, the water content in your concrete mix. It is very safe. So you can imagine that if I'm not using chemical admixtures, you can save more than the 5% and the 10% that I'm talking about. So this is the economic benefit of using this kind of materials. So what are some of the advances that we've made around the world? It is not only a Ghanaian issue, it's around the world. Okay, so now we're talking about LC3 cement. Now, what is LC3? LC3 is basically reducing clinker factor to 50% and adding calcined clays and limestone together with 5% gypsum. So why is it so important? It's a vast term in the world. As I initially mentioned, there's a professor in EPFL, Professor Karen Scrivener, who has been working so much on LC3 cement and pushing. Now he chairs the Energy Committee. He's part of the Energy Committee on the IPCC. And as I'm talking now, she's also in COP20, the COP meeting in Egypt. So we found that, when you reduce clinker factor by 50% and replace it with these cheap materials like clay, pozzolana, and the limestone, you invariably reduce the cement costs. And then you also reduce the carbon footprint of concrete. In the next slides, I'm going to share with you the carbon footprint of concrete. So let's look at how the carbon footprint performs, and that is an environmental issue. Of course, you see, in the world, every plant that produces cement generates approximately 1 ton of carbon dioxide. The point is that most sub-Saharan African countries are net consumers of cement. We don't have so much of plants that are producing cement like the developed countries, like China, India, and some part of the Asian countries. They produce so much of cement. So in sub-Saharan Africa, we don't have that. We also don't have other companies that generate so much of carbon dioxide. So we are net consumers of cement. This graph is showing the consumption or the generation of carbon dioxide. Now, by the IPCC, the threshold is 2.7 kilotons. But when you look at on this graph, you see that Africa, sub-Saharan Africa, is way down. We don't generate so much of carbon dioxide in the atmosphere. So who cares? If you're not generating so much of carbon dioxide, why do we have to bother ourselves with what the Europeans and the Americans are saying that, okay, everybody should think about carbon dioxide emission and let's make the world safe. After all, I mean, when they are having energy problems, they are trying to go back to the use of coal. But that's not the issue. The issue is that both the producers and the consumers contribute to carbon footprint. In my next slide, let me walk you through carbon footprint in the world. So what is happening is that I think we generate about 60 billion tons of carbon dioxide in the world. The cement plants are contributing between 8 to 10% of this carbon footprint. Now, the point is that as the carbon dioxide comes into the atmosphere, it actually prevents the sun that generates the heat on the atmosphere to escape. So when it's not escaping, it means that the heat is remaining in the atmosphere, and then somebody say it cooks the earth. So whilst it cooks the earth, we suffer. Now, the world has seen that if we don't take care, and now we see we are around 410 parts per million. And if we don't take care and we go to about 550 parts per million, it is going to generate a serious catastrophe for the world. You and me, we can't survive on this earth. So we are doing a very possible best to reduce our carbon footprint so that we don't trigger. So that is why it is important for every country to do its possible best to minimize carbon dioxide footprint. Well, so the effect of these things is the cause of rising sea level. So now, as the earth is cooking up, the glaciers in the Baltics and the Russians, the cold parts of the world, are melting up. And as it melts up, it increases the volume in the sea. And that triggers flooding and many things that is happening around the globe. It is also cooking the earth. It is cooking the land. It is rising temperature on earth. And we are experiencing global warming. Of course, I mean, you go to other countries and you see that the weather pattern has changed. And I mean, everybody listening here will accept that, yes, the world is becoming warmer and warmer. And then we are also having, we are also having increasing temperature on the sea. So the earth is warming up, the sea is warming up. Now, if you look at the science behind the increasing temperature of the sea, it means that is what generates all the hurricanes that is happening in some parts of the world. It brings currents, and then we hear of tsunamis, we hear of Hurricane Katrina, Hurricane whatever, Hurricane Charles, Hurricane whoever that they want to name with. So that is it. Global warming is not an interesting thing for the world. The science have proven it, and there's so much data to back that, yes, global warming is occurring, and we need to minimize carbon dioxide generation in every country. Well, so if we have to minimize it, so what is the cement plants doing? What is the concrete industry doing? As I've already mentioned, the concrete industry is contributing between cement and concrete industry is contributing between 8 to 10% of the global carbon dioxide emission. Okay, so this is a work that was done by the American concrete industry some years back. They look at replacing cement by supplementary materials. And so look at the graph very well. So this is a ready-mix concrete that is containing about 335 kilograms. Now, that is the embodied, when I say embodied energy is the total amount of energy that is used to produce the concrete. And the embodied energy of a material is directly proportional to the embodied carbon. The embodied carbon is the total amount of carbon that is being generated by a material. So when they use about 395 kilograms of cement in a concrete mix, the embodied energy was a little about 1.6. But you realize that as they reduce it and replace it with supplementary cementitious materials, the embodied energy reduced, right? So for example, 30% of it, let's say 35% of slag, the embodied energy was a little below 0.9 as compared to when there was nothing. So it can be concluded from the work that was done years back by ACI that replacing cement or clinker with a supplementary cementitious material reduces the carbon footprint of cement. Yes. So that is why a lot of people are advocating for the use of supplementary cementitious material. Okay, so this is a work I did recently. I did two things. I look at carbon savings and I compared with it what I call efficiency factor. Efficiency factor is very important when you want to use supplementary cementitious materials. So what is efficiency factor? Efficiency factor is simply looking at a grade of 1. There is a calculation for efficiency factor. There are articles on it. You can, if academics people are around, they can find out. You can contact me. I can teach you. So what you do is that you have a score of 1, and then you are replacing the material. If the material you are replacing, you calculate the efficiency factor, and it is below 1, then it means that you can't replace the material with cement. But if you replace with cement and you have an efficiency factor of above 1, then it means that, yes, the material can replace cement without compromising the properties of cement. It's as simple as that. So I did efficiency factor and carbon savings when I replace pozzolans between 0 to 50%. Now, look at something. The blue line is, the blue dots are showing carbon savings. So, of course, when I replace cement with the pozzolana, I'm having a high savings in carbon. You know, as it goes to 40%, you know, you see that it keeps on increasing. Now, the efficiency factor is very key because you can have carbon savings and then at a point, your efficiency factor is not too good. Okay, so when you look at the orange dots, it is the efficiency factor. So for example, if I look at 10%, I'm having efficiency factor above 1. Between 10 and 30, all the efficiency factors were above 1. But when I came to 40, the efficiency factor fell below 0.6. So the thing is that, yes, you are increasing, you are making carbon savings, but when you go above 30%, your efficiency factor falls down. So that one should give you a key to how to optimize your material. So with this clay that I used to produce my pozzolana, my optimized material was at 30%. Some clays can optimize the material above 30% when you look at the efficiency factor. It is a very key thing when you are doing this kind of work. Okay, so let's continue. So after doing this efficiency factor, I also did some work on carbon emission and environmental impact. This is also very key. We have environmental impact and total carbon emission. In this area of cement science and concrete, you have to be mindful of these two things. We have the carbon emissions, we have the environmental impact. So environmental impact is a ratio between the total carbon of your material you are generating against the strength you are achieving at the required time. And in the standard, the required time is 28 days. But when you are using pozzolans, because pozzolan has a late setting time, we actually require to go above the 28 days. So I did this graph to match total carbon emission of the material against environmental impact. Now the blue dot is showing the embodied carbon, that is total carbon. So as you go by using so much of the material, you reduce the carbon footprint. All right. But what about the environmental impact? The environmental impact at 28 days will also be lower. Right. So, for example, at 40%, the environmental impact is lower than at 30%. Right. So it means that we have an appreciable environmental impact at 30% than the 40%. At 90%, at 90 days too, there was a strange thing that happened. At 90 days, at 50% of my replacement, I have a very high environmental impact. So it means that when you cure your material more than 28 days to 50 days and 90 days, you are achieving a higher environmental impact as compared to this. So the key thing that is important here is that at building professionals, do we settle on 28 days as the main time of curing if we really are thinking about carbon emissions and environmental impact? So that one should be driving as when we are doing construction, because there is a vast difference between curing at 28 days and curing at 28 days. So if your project is not a project that is not of time bound or whatever, you can actually slow down and then let the thing cure very well and then achieve a proper high strength. However, there have been projects that I have done that they require higher early age strength. So I dope it with accelerated to achieve higher strength at early ages, but it also comes with a cost. All right, so I always show practical examples of works that have been done. So recently, I'm championing a project at Cape Coast University, building the Department of Marine Science. Now, whoever knows Cape Coast may know that they have the sea in Cape Coast, and almost every place when you dig deep, you will get the water coming out, and the water is much of sea water. And that's one of the good things about the pozzolana cement concrete. I've shown you that it has a lower ingress to chloride. So we did a mix design for them using the pozzolana. So now just enjoy this video. So this is a concrete van. Make no mistake, we have done a concrete mix design already. So everything has been measured for the van, and the van is going to mix the concrete using the calcined clay pozzolana under the cement, and then they will produce the concrete. So this is a C30 concrete, but after we did this work, we were able to achieve about 38 megapascals. So we did it very well. We used a polycarbonate heater, which can reduce water by 40%, and then we're there. So this is also the concrete plant, the van pouring the concrete. This is a rough foundation work. And I'm telling you, this is a calcined clay pozzolana concrete. It used 30% of calcined clay or clay pozzolana. Now we also did this. No, the first one was a mobile van, and this one was a concrete mixer. For people not to ask that, okay, why were you using mobile van? You didn't use normal concrete mixer. So this is a concrete mix. We proportion the mix for them on site using the various components, and then they do it well. The problem sometimes we have on site is that people have problem with proportional. And so that is why we in BRI are there. I have trained a lot of people. You contact me, this is a super plus sizer. You know, you contact me, we can do it for you. They come to site and then monitor your work for you. And then you can make savings on costs and the environmental. So with this concrete, I call it a low carbon concrete. And I'm going to document this and then share it in some conferences that I may attend in the future. And so, you know, the guys were happy. They were just driving the thing and then pouring it on the rough foundation. Yes, and that is a low carbon concrete. I'm also happy for this work because it's one of the main work that I've done this year that at least the contractor was so happy. It's a World Bank project. The World Bank people were very happy over the project. Well, I've talked at length, 18 pages to 20 pages. Don't worry, I'm going to conclude. So in conclusion, the use of clay pozzolana has technical benefits. It improves the strength and transport behavior of cement-based products. Yes, you have seen from the plenty talks that I have made. Now, it also enhances the longevity of structures. That means that the service life of the structure is enhanced. Why the service life is enhanced? We all know that carbonation and then chloride ingress affects the surface life. It creates corrosion of the rebars, which can lead to extreme cracks expansion. So once there is higher resistance to it, you are going to enhance the service life. It's so interesting. We calculate service life for people. There's a project I did on the Owabe and the Barakesi Dam recently, and they were interested in the calculation of the service life of the dam. So you need all this data to look at the service life of the dam. And then if you have an idea of how resistance your structure is, you can actually calculate the service life. So now from all the deliberations and the data and everything that I've shown, you can see that, of course, clay pozzolana can impact positively on the carbon footprint in the cement and concrete industry. Now, let me do some recommendations. It is funny. My recommendation is very funny. They say charity begins from home. Why am I saying that? Sometimes, I know I started this pozzolana thing a long time ago. You can give fancy presentations in conference. People will come to you, hey, you've done a very nice presentation. Oh, come on. But it ends there and everybody moves away. You go to meetings like this one that we've organized. The thing is that people are just interested to make a name of how well the program went. But the practicality of it is always missing. Now, I would like to recommend that if people here are all contractors, consultants, please start using this product. Now, for me to be a disciple of the product, every project that I do, I use clay pozzolana. To the extent that I recently did the work for my mother, I use 50% of clay pozzolana and 50% of cement for the plastering. Everything I do, I use clay pozzolana. So if we have 20 members here and everybody is going to say that, okay, from today, every project I will recommend clay pozzolana, I think we will make a headway on the carbon footprint and the use of local content. This is my second one. Of course, we lead policy initiative from government. So if government rep is here, like the assemblies, you know, I sometimes, I know that some people are in the assemblies, they talk big, they always want to be seen on program. But when you go to them, they don't even use it. So then why do you talk about these things? You know, we have to be using it in our assemblies, and we have to initiate it when we go to the local government industries that, yes, this product is available. And the government should also try to make headway of using this product in the school buildings and, you know, those kind of projects that we are doing. Okay, so thank you very much.